Hello, my teachable students. I welcome you to our special class where we present the simplicity of the science subjects. I believe you are following the teachings and you have listened to how I make use of Katua and Pythagoras theorem to solve problems that are related with right angle triangles. Okay, so if you are here to watch any of our video, I will advise you to click on the link in the comment section that will direct you to all our videos, all right, from the first problem to the last problem I solved under the use of Katua and Pythagoras theorem to solve problems that are related with right angle triangle. Today, I'll be explaining on how to solve problems that has to do with angles of elevation and angles of depression. All right, so I want you to be more attentive as I'll be explaining many things under this topic: angles of elevation and angles of depression. Whenever angles of elevation and angles of depression are mentioned, just have it at the back of your mind that there is an observer, and the observer will either be looking up at a tangent object or be looking down at a tangent object. But just have it at the back of your mind that there is an observer whenever angles of elevation or angle of depression is mentioned. Another thing, when you are dealing with angles of elevation, just have it at the back of your mind that the object is always up. So under angles of elevation, the object is always up. So the eyes need to be lifted up to look at the object up. That is under what? Angles of elevation. Alright. When it comes to angle of depression, okay, the object is down below the eyes level. So there's a need for the observer to look down under angles of depression. Okay, so in angle of elevation, the observer will look up because the object will be up above the eyes level. Did you understand that now? Okay, and don't forget that angles are measured in degrees. Is that one clear? All right, so let us start with what? Angles of elevation. Let me read out what I have in my notes here. The angle of elevation is the angle between the normal height level, in bracket I have horizontal line here, and the line through which an object is above the observer's eyes. Okay, so from what I read here, okay, they said angle of elevation is the angle between when I say between, I talk about two things. Between the first one, the normal height level. Now, every height level is always horizontal. Okay, from that your height, just draw an horizontal line from that your height. We call that normal height level. So they said angle of elevation is the angle between the normal height level from the height like this, horizontal line from the height level. So between the normal height level and the line of sight. Now the line of sight is a slant line, a line that runs from the eyes to the tangent object. All right. So when the eyes is lifted from the highest level, normal highest level, to a tangent object, so the angle between the line of sight and the normal highest level is called what? Angle of elevation. Did you get my point? It's called what? Angle of elevation. And have it in mind that angles are measured mostly in what? In degrees. Now, every problem under angles of elevation and depression, all right, end up with right angled triangle. Any problem that has to do with angle of elevation and angle of depression end up with what? Right angled triangle. Meaning you can make use of either Socatua or Pythagoras theorem to solve problems, okay, that has to do with angles of elevation and depression. Are you with me? So now, from what I have here, if you just go to the object that is above the height level and you draw a vertical line down to the height level, you're going to end up with right angle triangle, and that's what you have here. You end up with what? Right angle triangle. So when you draw a line, a vertical line, not slant line, a vertical line from the object above the eye level down to the horizontal line, you will end up with right angle triangle, and that's what you have here. Of course, we said every triangle has three sides, three angles. So let me explain the name of this side of the right angle triangle as regard angles of elevation. The normal height level, which we call horizontal, we can regard that as base, as ground. No, ground is always horizontal. We're talking about the earth surface. Foot, right? Then shadow cast on the ground. So all these are synonyms of horizontal line. Now, when it comes to the vertical line here, that one deal with height. So what is height? Height is the gap or distance above the ground. So we have our height here. It's above the ground level here. That's our height. Then this line of sight is the hypotenuse. All right. So the line of sight is always hypotenuse. Why? It's facing the right angle. You do understand that now? So let us take an example under angle of elevation and depression. That is example 7. So let us listen to the problem we have in example 7. As I read, the angle of elevation of the top of a tower from a point on the horizontal ground 80 meter from the foot 80 meter from the foot of the tower is 60 degree. The question, find the height of the tower. All right, so if you look at this question here, they gave us two values. One is 80 meter, the other one is 60 degree. Do not forget, I said angles are measured in degrees. So between the 60 degrees here is the angle of elevation, and the 80 meter is the horizontal distance between the foot of the tower and the observer. So now look at the diagram. Okay, whenever they mention angle of elevation and depression, to make things easy, just draw a right angle triangle and put in the values at their right places. All right. So now we said angles of elevation is the angle between the eye level, which is horizontal, and the line of sight. So that's why we put the 60 degree here between the horizontal and the slant height here. All right. And the vertical line here is the tower, and this is the foot. And they said 80 meter away from the foot. So we put our 80 meter here, which is horizontal distance there. Of course, they mentioned horizontal ground here. All right. So now we have our 60 degree, which is angle of elevation. Then we have our what? 80 meter, which is the horizontal distance. Then the question says find the height of the tower. What is the height? I say height is the gap or distance above the ground level. Above the ground level. So we are looking for this place. So to solve this now, you square that what you are looking for, of course, we take that as x, is facing the given angle here. So that make it what? Opposite. And of course, the hypotenuse is the line of sight because it's facing the right angle. All right. And the 80 meter becomes what? The adjacent. So once you have your opposite and hypotenuse, the 80 meter becomes what? The adjacent. So we are using the 80 meters, okay, to find the value of x. All right. So x is O, which is opposite. 80 meter is A, which is adjacent. So OA, we can get that in TOA. So to be tan 60 degree, tan the given angle 60 degree is equal to opposite, which is our x, over adjacent, which is what? Our 80 meter. So tan 60 degree in fraction is root 3 over 1, which is equal to what? The x over 80. So what you do from here, since you are dealing with equation, you cross multiply. So x is multiplied by 1, that gives us x. And 80 is multiplied by root 3, that gives us what? 80 root 3 in meters. Okay, in meters, because what you are given here is in meters. All right. Of course, that x is the height that we are looking for. Therefore, the height of the tower is, I hope you understand. It's so simple. Of course, I start with the simplest example under what? Angles of elevation. Did you get that now? So let's meet in our next uh, video for more examples under angles of elevation. All right. So please just go to the comment section and click on the link so that you can watch all our videos. All right. It will help you to add academic value to you. All right. So from DFM Mike Mattis, I say thank you and bye for now.